All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.6 in Algebra 2, which is radical expressions and radical functions. This is the first video of this section. So we've seen a lot of the topics in this section before in some fashion. So here we're going to focus on a couple of big things. Graphs of the square root and the cube root of x, domain and range restrictions on roots, transformation of functions, which we saw way back in Chapter 2 as it applies to these graphs, finding the inverse of a quadratic function, which we've seen a little bit of in 2.5, and evaluating roots by hand. So we've done some part of most of these before, but we're going to continue working on them and flesh out these topics a little bit. So let's start with the square root of x graph. So I was kind of lazy when I was typing, and I just used the square root, but so this is the same as this, obviously. So y equals the square root of x. So this is the square root graph, right? It's got the point 0, 0, 1, 1, because the square root of 1 is 1, 4, 2, because the square root of 4 is 2, and 9, 3, because the square root of 9 is 3. So let's talk about the domain and range for a little bit. You can see from this graph that the domain starts at x is 0 and goes this way. So the domain is essentially 0 and higher, right? So x is greater than or equal to 0, or you could write it as 0 to infinity like this, right? 0 to infinity, right? The range of this thing also starts at 0 and goes up. So the range of this thing is also 0 to infinity, and the logic behind that is you can't have a negative output from an even root. So the square root of something always has a positive output unless there's a negative in front of the root already. Like a negative square root of x would have a negative output, right? So a couple notes about domain, right? So we know that the inside of an even root has to be greater than or equal to 0. So that means that the domain of an even root function, like the square root or the fourth root or the sixth root, we set the radicand, which is the thing inside the root, greater than or equal to 0 and solve for x. A note about the output of an even root is that it is non-negative, meaning that the output of a root of the even root is greater than or equal to 0. So you can determine the range by setting the root output as 0 to find an endpoint and then figure out if the range is above or below that endpoint. So let's go ahead and walk through some of this. So we're going to find the domain and range of this function. So let's start with the domain. So for the domain, right, the inside of the root has to be greater than or equal to 0. So 3x has to be greater than or equal to 5. X has to be greater than or equal to 5/3. You can write it as that. So there's a bunch of different ways to write it, or you could write it in parenthetical notation, which is, of course, my preference, but it's up to you, right? So you could write it like this, or you could write it as x is greater than or equal to 5/3. That's fine, too. Now, for the range, right, for the range, the output of an even root has to be non-negative. So this whole thing has to net positive or 0. Well, what that means is that the range of this function, right, the range of this function is going to be greater than or equal to 0, because the entire function is a root, and the output of an even root is non-negative, right? So you can either write it this way, or you can write it as a 0 to an infinity. And you can see that if you were to graph this, right? So if we were to graph in our calculator square root of 3x minus 5, right, and we graph it, you're going to see that the range, right, so sure enough that the range is from 0 upward, right? We can see that, again, we can confirm in a calculator that the range, right, the lowest values here, the range is from here up, right? That's my range from here going up, and my domain is from here, which would be 5/3 going this way. That would be my domain, right? That's where the graph exists. All right, so go ahead and try that with P1. Again, you're going to find the domain and the range, right? So the domain is going to be that 2x plus 7 has to be greater than or equal to 0. 2x is greater than or equal to negative 7. X is greater than or equal to negative 7/2. Again, I like parenthetical notation, but you don't necessarily have to use it. You can, unless you're specifically required to do so. All right, so there's my domain, and then for my range, right, so for my range, again, the entire function is an even root, right? There's nothing outside the even root. So this even root has to be 0 or positive. It can't possibly be negative. That's not how even roots work. So y is greater than or equal to 0, or you can just write it as 0 to infinity for the range. And again, we can confirm that by graphing. So if we go here and make this a 2x plus 7 and graph, you'll see that sure enough, my range is 0 to infinity, right? The graph goes up from 0, and the graph goes right from -7/2, right? So you can confirm that if you look, the range starts at 0 and goes up, and the domain starts here at -3.5 and goes to the right. So -3.5 to infinity. All right, so let's try that again. So we're going to go ahead and find the domain and range of this function. So the domain is that x squared minus 2x minus 3 has to be greater than or equal to 0. Well, we've seen this before. This is a quadratic, and when we solve quadratic inequalities, we essentially factor and make a sign chart, or factor and, so what we have to do is we either factor and make a sign chart using the factors in the sign chart, or we make a visual sign chart recognizing this is a smile parabola, right? So we need to find the roots, right? So we need to find when x minus 3 is equal to 0, which is going to be at 3, and when x plus 1 is equal to 0, which is going to be at -1. So you can either make a sign chart like this. You can recognize that this is a smile, right? So this function right here is a smile because the x squared has a positive in front of it. So it's going to look like this, and since you want when this thing is positive, your answer is going to be here and here, right? So your domain is going to be -infinity to -1 with a bracket, and then again from 3 to infinity. That's fine. The other way to do it is to make the other sign chart, the one that lists the factors. Honestly, with something that's a quadratic, I don't usually make the physical sign chart where you have to list the factors because it's usually not worth it, right? In terms of the amount of work that you have to put in, this is usually not worth it. But you could, right? It's the same concept. It really depends on your comfort zone. I definitely make this kind of sign chart with a more complicated function than a quadratic. So I know that x minus 3 is a line with a positive slope, so it starts below the axis, crosses 0 at 3, which we already found up top, right? Here's where we cross that axis, and then becomes positive, right? I know that x plus 1 also is a line with a positive slope, since it's 0 at -1, which we found up here. It's negative before it's 0 and positive after, so I get positive, negative, positive, and that gives me the same two answers that I just got up there. And again, if you don't feel comfortable with this, you could have picked easy numbers to plug in, right? You could say, hey, what's a number smaller than -1? There's -2. What's a number between -1 and 3? Well, there's 0. And what's a number between 3 and infinity? Hey, there's 4. And if you plug those numbers in, you'll get these positives and negatives that I got. So either way, there's my domain. Now let's talk range. This entire function is a root. The output of an even root is 0 or positive, can't be negative. So the range of this function, since the entire function has a root on the outside, is y is greater than or equal to 0, right? So my range, the other way to write it is bracket with a 0 and then to an infinity. Now let's go ahead and graph this just to confirm, because I want you to see what these things look like. So we'll do square root x squared minus 2x minus 3. All right, and we'll graph. And sure enough, you'll see that this function only has a domain on those two sides, right? So it only has a domain on those two windows. There's that weird empty space in the middle where it doesn't have a graph, right? And then I know it's hard to see that the range actually goes down to 0, but it does. This is a limitation in the pixels of your calculator. It does actually go down to 0. It's just a limitation in the pixels of your calculator. So your range definitely starts here and goes up, right? And that's what we see in red here. And your domain is from here and over, and from here and over, and that's what we see here in green, all right? All right, let's go ahead and try a P2. So you're gonna find the domain and range of this function. So same idea, right? The inside of my even root has to be positive. So when we do my domain, x squared minus 5x plus 4 is greater than or equal to 0. If I factor, I get an x minus 1, x minus 4 is greater than or equal to 0. And then I need to find the roots, right? So x minus 1 is 0 would give me x is 1. X minus 4 is 0 gives me x is 4. I would again argue that this being a smile, right, there's a positive in front of the x squared. I would argue the easiest option is just to make a visual sign chart with a smile through the two roots, right? And then you're going to find out quickly that your two answers are here and here, right? So if you do that, your domain is -infinity to 1 with a bracket, and then again from 4 to infinity, right? Just double checking that I used brackets on the last one. I did. Cool. All right, so that's fine. You can also make the other kind of sign chart. I really don't have a preference. With something as straightforward as a quadratic, I think that the visual sign chart is a little easier. For the range, again, notice that this even root is the outside of the entire function, right? This even root has to have an output that is non-negative, so 0 or positive, meaning my range is y is greater than or equal to 0, or you can write it as 0 to infinity. So if we go ahead and put this in the calculator to confirm, I'm basically just going to overtype the -2 with a 5 and the -3 with a +4. And that should give us what we need. And sure enough, you can see that we're looking at a very similar situation. And soon we'll see one where the range is not just greater than or equal to 0, but I just want to show you that that's kind of how this works. So again, you can see that your range is from here up, right? So that's 0 to infinity, right? Check. And that your domain is this window from here over, right? So that's a 1 to a negative infinity, right? Or negative infinity to 1 if you're writing it in order for your interval, and then 4 to infinity, right? So that checks both of those off. All right, cool. So that's it for our first video.